All right, I got cut off in the last video. That's because it went to 15 minutes, and that's as long as I can go. So this is going to be a two-parter, folks. So we're going to come right back to our wagon wheels here. We got 45-degree increments over here. We got some 30-degree increments over here, and we're going around the horn. That's what this is, around the horn. Now we can need our benchmarks. 0 degrees. That was also 2 pi radians from our previous conversation. 180 degrees is pi. All right, so we're just dividing this up into fourths. Fourths and halves. Basically, if you got pi radians is over here on the left side, that means in the middle we've got pi over 2. It's equivalent to 90 degrees right there. If you cut those halves in half, you got pi over 4. And then you go 1/4, 2/4. You're literally counting around the circle. 1/4, 2/4, 3/4. So 3 pi over 4. And if you just keep going, you got 5/4 of pi. 6/4, which we call 3 halves because it is 3 halves. And then that's going to be, so 1, 2, 3, 4, 5, 6, 7 over here. 7/4 pi. And then we get to the end, you're at 8/4. All right, so that's just counting your way around the unit circle in fourths and halves. You're literally saying 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7. It's kind of like an 8. It's like a pizza with 8 slices, 8 equal slices. That's truly what it is. If you were to cut this up, that's what you're doing. Cutting it up into slices, going around. The only thing is that a pie is not a whole pizza. A pie over here, don't forget, pi is half of this whole circle. I know it doesn't make sense, but they weren't thinking about food when they did this. Go watch Vihart's video, Pi is Wrong. Google it, Vihart on YouTube. Pi is Wrong. It's a great video, but unfortunately she's not going to change the world. So let's come on over to the 30-degree circle. And literally, we're just going 30, 60, 90. Well, we know 90 already. I'm going to put in the benchmarks I've already got. I already know these ones. So I'm going to put them in here. And then I'm going to say, well, it's just like that other circle. If I cut it into 12 pieces, then when I get to the end, I'm going to be at 2 pi or 12/6. So really think of the half circle as 6 is easier. That's just much easier. So you think of that as 1/6 of the half. 2/6, or as we know it, 1/3. So pi over third. It's a third of the half of the circle, if that makes any sense. If not, pause it, rewind it about 100 times until it sinks in, because that's actually the mathematics we're looking at here is fractions. I know, you'll love them. No, not really. So let's keep going. So we're counting our way around the circle. We got 1, 6, 2, 6, 3, 6. We need 4, 6, 5, 6, and 6, 6, 7, 8, 9, 10, 11, and 12/6. So we're just going to count in 6, and we're going to reduce fractions wherever we can. So I'm at 4/6 over here, so that's going to be 2/3. 2 pi over 3. And then we're right here. Now we got 5/6. You can write 5/6 pi, or you can write 5 pi over 6. It doesn't matter. But then you get to 7/6, 8/6. So that then we're counting. Then we're kind of counting actually in thirds too. I mean, you can think about this either way. If we do it in thirds, we're looking at 1/3, 1/3, 2/3, 3/3. This is actually 4/3 right there. 4/3 of pi. And then when we get to the end, we keep going a little further out. We go another third here. So that's going to be 4/3, 5/3 over here. And then our last one. Now if we go back to 12ths, we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 12ths. So this last little guy over here is, oops, wrong pen. 11 pi over 12. Oh no, sorry, not over 6. So what am I doing? Over 6. All right. So that's all the way around our unit circle. Check that out. Once again, play the games. And now we come to that last little bit of this, and this is all special right triangles. This is all based on everything we've done previously, which said if I have a right triangle and a 45 situation, that means the other angle is also 45 because they're isosceles. And we looked at it like this. We kind of said, you can think of this, we looked at it as a generic right triangle where you had side lengths of x, x, and x root 2. There's only one problem now, is that we're going to change that up a little bit, because this hypotenuse right here is actually going to equal 1, because that is going to be the radius of the unit circle. That's what it's going to be, the radius of the unit circle, and that is a length of 1. So we now have to kind of make some adjustments to our thinking a little bit, and just going back, if that's 1, well, what's x equal to? That's the question. And if you do the math here, we've already done it in class, so I'm going to kind of skip through a little bit of this, not too much, but a little bit, and say, you know what? You divide by root 2 and you rationalize the denominator, you get the square root of 2 divided by 2. Square root of 2 divided by 2. Square root of 2 divided by 2. Yeah, we could make a song out of it, but I don't have enough time in the day. So that's just the basics. Once again, if this is new to you, go back and recheck it. Check it, check it, check it. Okay, I'm going to go back over 30, 60, 90. Here we go. That's a 60-degree angle. That's a 30-degree angle. And if you remember the general form, it was short side was 1, or x. The long side was twice as long as the shortest side, which is 2x. And the tall side here was x root 3. And when we see that, once again, we see that the unit circle is a little different, because the hypotenuse is, once again, that's going to be the radius of our unit circle. So that's going to be 1. So now we have to kind of work our way back from that. If that's 1, we back it up. That means this will be 1/2, and it means that over here will be 1/2 root 3, or what we call root 3 over 2. Now that's the basics of the special right triangles. Okay, so that is how we get the side lengths of those triangles. Then we actually put them into the unit circle. So if I put a 45-degree angle on here, what I create is a special right triangle, where this is 1 root 2 over 2 and root 2 over 2. The only thing is that you can go around that circle and find another 45 degree. There's one over here. There's one here. There's one here. They're all the same triangles. So they have all the same reference angle, if you will. They all have the same kind of, in the triangle, they all have this 45-degree thing going on here. So they all have the same side lengths. And this sounds weird, but these are all the same triangle. They all have a radius of 1. They all have side lengths of root 2 over 2. The only difference, oops, not there. The only difference is that you got to know where x and y are positive and negative. They all have the same numbers, but not all the same signs. So in the first quadrant, remember quadrant number 1, x is positive. Y is positive. Don't forget that. You need it. Over here in quadrant 2, x is negative. Y is positive. Don't forget that. Quadrant 3, what I call the quadrant from hell. Everything's negative. Negative x's. Negative y's. Oops. That's just too much information. Negative y's. Okay, so everything's negative there. That's what we're talking about. And then over here in the fourth quadrant, x is positive. Y is negative. So all you have to do really is go back and put on, if you get this idea of these four triangles being the same, the side lengths, it's really just a matter of what's positive, what's negative. So when it's over here, I'm going to go over to quadrant 3, the quadrant from hell. Everything's negative. So in other words, that x value here, this x coordinate right here, is going to be root 2 over 2, but it's going to be negative. And the y coordinate of that, so that's going to be up here, that is going to be, same thing, root 2 over 2, but negative. And what that is, you may not even see this yet, but I'm going to blatantly point it out. That is the coordinates of the point on the unit circle. That's what that truly is. It's just magical and brilliant, but not really. It's the unit circle. So let's take a look at the 30, 60, 90s a little bit. Let's go over here and plug some of these in. Here's our crosshairs. That, by the way, just so you know, that is the x and the y axis. Hasn't changed in 5 billion years. Let's put 30 on here. Oops. Let's put a 30 on here. And let's put a 60 down here. And then we'll connect the dots. So this is a 30-degree angle. And if you go back to the video about the 30-degree angle when that side length was 1, that radius. This little guy was 1/2, and this little guy over here was √3/2. And so the coordinates of this point now, we can go right at it. Let's go right to it. The coordinates of that point are, the x value is √3/2, and the y value is 1/2. You can go to the 60, you do the same exact thing. You just put in the, first of all, what you know, the side lengths from the special rights. That means our radius is 1, short side still 1/2. High side over here, still √3/2. The only difference is now that the y is negative. So when you go to this coordinate down here, it's got an x coordinate of 1/2, but a y coordinate of negative √3/2. All right, this is all in the game. So once again, play the games, play around with this stuff. There's a little more to this story, but not too much. I'm going to finish it up here with the last bit and piece of this, but I do need a circle. There's my circle, close enough. Need some crosshairs. There's my x and my y axis. The last piece of this is really, it's not very far-fetched, but it is unique. If I take an angle, and I go out and on my unit circle, I make my right triangle. Oops, right triangle. And I say, well, you know, this little side over here on the bottom, my short side. Let's go with short side first. That guy right there. That's my x distance, if you will, my x coordinate on the point that's on the circle, which is out there. Well, there's something we know about sine, cosine, and tangent. And we do know that the sine of this angle right here, if we just call that theta, the sine, or actually, let's go with cosine. The cosine of that angle is equal to the adjacent side, which is right here. This is my x value, that's my x coordinate, over the hypotenuse, except in this case the hypotenuse is 1. So what this tells us is this, that dividing by 1 doesn't matter. So that x is the cosine. That is the x coordinate up here. So we can actually put that right in here and say, if these coordinates, the x coordinate is the cosine of that angle. And then if we do the same thing over here with y, we get something similar. I'm just going to make an arrow over here to where we're at. We take the sine of that angle, that theta, that should be the opposite side. So opposite here is going to be this y coordinate, the y coordinate of this point. Should be y over 1. And once again, that's because the hypotenuse is 1 in the unit circle. We really can just say we don't need it. The y coordinate is the sine. I know, some of you missed the Zoom meeting today. You missed that. I know it's not in the book. It is not in the book. It's the unit circle info. So that's, we can now actually say that the coordinates of any point on the unit circle at this point, we have an expression for them. We can say those coordinates are the sine. The x value is the cosine, the y value is the sine. That is it, folks. That is a 2-part series. We're done. It's Friday. Beaches are open. Should I do it? Yeah, why not? I'm going to do it right over this. Oh, except that is just too much in the way. Don't want any crosshairs in the way. Have a great weekend, all. See y'all on Monday. Out of here. Sayonara.